Okay, this is 4.3, multiplying polynomials continued. We just covered the FOIL method. We're going to do something similar here. We've got 3x minus 4 times x squared plus 2x minus 5. What I'm going to do is I'm going to break it up into two pieces. 3x times x squared plus 2x minus 5, and then minus 4 times x squared plus 2x minus 5. So essentially I treated each of these as two different things and I broke it up. Now I use distributive property. Okay, so 3x times x squared plus 3x times 2x plus 3x times negative 5. I also do distributive property on the other side. Minus 4 times x squared minus 4 times 2x minus 4 times negative 5. So put those things together. That is 3x cubed plus 6x squared minus 15x. That's minus 4x squared minus 8x plus 20. Bring it all back together. Common terms, 3x cubed is by itself 6x squared negative 4x squared. That gives me positive 2x squared. Negative 15x, negative 8x, those are common terms, they both have an x. That gives me negative 23x, and then 20 is by itself, so that gives me positive 20. Okay, so again, we just break up each piece, and we distribute it. Okay, let's look at some of these examples. All right, these examples, we have a couple of special products. That's what they're called, special products. We have a few different things. I'm going to write them here. If I have something that falls in the form a plus b squared, it always multiplies out as a squared plus 2ab plus b squared. However, if it's a minus b as a quantity squared, I get a squared minus 2ab plus b squared. It's very important that you recognize these patterns. They will make your life easier in the long run. Now, if I have something like this, a plus b, a minus b, that gives me a squared minus b squared. These patterns work all the time. All you have to do is figure out what a and b are. Okay, these two here, these are called perfect square trinomials. And then this here is called the difference of squares. Okay, so we're going to do these. Okay, x plus 2 squared. That follows the first one. So that tells me a is equal to x, b is equal to 2. So I know that becomes a squared, that's x squared, plus 2x times 2 plus 2 squared, or simply x squared plus 4x plus 4. It follows that form. That is a squared plus 2ab plus b squared. Do the same thing here. It's a minus b squared. In this case, a minus b, a is equal to 5x, b is equal to 3. Okay, a minus b squared is a squared minus 2ab plus b squared. So this is a squared, 5x squared, minus 2ab, not negative 3, b is positive 3, b plus b squared. So that's 25x squared minus 10 times 3, 30x plus 9. Follows the pattern. A minus b squared is a squared minus 2ab plus b squared. I do it. a minus b squared is equal to a squared minus 2ab plus b squared. Our difference of squares, remember this is a plus b, a minus b is equal to a squared minus b squared. So in my case, I have a is equal to 3x, b is equal to 1. So this gives me 3x squared minus 1 squared, or 9x squared minus 1. A plus b, a minus b, a plus b times a minus b is a squared minus b squared. Match them up. 3x1, 3x1, so that's a and b. This is a little different, but this falls in the same form. This is a plus b times a minus b, so that's a squared minus b squared. So in my case, I have xy sticks around, that gives me x squared minus y squared. And then I use the same properties before. I have xy times x squared plus xy times negative y squared. So I end up getting x cubed y minus xy cubed. And that's how that one works out.